right, it is August 5th, 2019. And I noticed that some of you were very savvy and checked on the class website. Noticed there was an extra credit assignment posted last Friday, and some of you did it. I tried to send on the email because normally that's how I would operate, is I would just do an email blast to everybody, but that was broken. But please get in the habit of just checking the class website on Friday evenings, so that if there is an extra credit assignment, you have an opportunity to do it. I am going to extend that extra credit opportunity, so if you haven't done it, you have until next Monday, okay? And those are usually due before class starts on Monday, so get to school on time and get it to me before the day begins. And just so you know, I don't check my email when I get home. Okay, so if it's on the weekend, I'm usually not going to check it. That's just because, home time is home time for my family. So, but know that I do answer email, and I do check it before I leave. So if you can email me before the end of the school day, then I can get it. If not, then it'll be the next day. And please, if you're ever absent, just go to the class website and through Student View. So the app doesn't work, but log in through a web browser and check that class website. There's a button on the left side, and you got to change the drop-down menu to Good Now, and then you'll see all the posts. And hopefully, you'll be able to stay on top of things. I am going to try, because I know you guys don't have textbooks at home, though if you wanted one, you could probably get one. Air, hot, right? Hot. Okay. You probably can check out a textbook from the bookstore if you want one to have at home. And that would probably be a good thing. Okay, but I am not sure if we have enough. I expect we have enough. So you are more than welcome to take a book home and have one at home. That would be useful. I am going to try to take a picture of the homework or the classwork problems every day and post that to the class website as well. But that might be sort of a hit or miss sort of thing. Like, oh, I remembered today. Oh, I forgot the next day. So don't count on that. All right. So I hope you're getting your materials and that sort of stuff. I will be sending out an email again. Hopefully it works today. It'll have the syllabus. So for those of you that were just added in, look for an email. The syllabus synopsis, the materials list will all be coming, and encouraging all of you to check the class website. Okay? We're working with radicals today. So we've been on this section for a while. You will have a quiz very, very soon. Your first quiz, I know you're all super excited, on 8.2 and 8.3. I'm not exactly sure when that's coming, but I will let you know as soon as I have those all organized in my brain. Sections 8.2 and 8.3. These are, it's kind of a nice hey, pay attention. Okay. So today we're talking about radicals, and I know that you all know how to find the square root of 9. Explain to me how you find the square root of 9. So you find the root as in the number that multiplies by itself, that gives you 9. Okay. So when I teach this to Algebra 1 students, I have this whole story about this is cell block number 9, and in cell block number 9, inmates 3 and 3 are in the same cell. They're cellmates. Okay. And this, I know, it's very involved in bloody and gory because that's what people remember. But this number is a 2 when nothing is there, and that is called the index. And that index in the little elbow there is very, very important because it tells us how many we need. So in this case, cell block 9, God bless you, breaks down into 3 times 3. And this little index tells us that we need 2 of a kind, okay? A pair of 3s. If we have a pair of 3s, one gets shot and his friend escapes. That's why you always got to have a buddy if you're going to escape from jail, okay? All right. All right, so that's the quick and dirty story. Okay. Right? So then, if you have like the fourth root of 16, the same scenario applies, right? So in this case, the index is 4, but the story is the same. 16 breaks down into a lot of 2s, okay? Is it just 4 2s? Yeah, okay, good. Just, thank you. My math is not so good, just so you're aware. Okay. So 16 breaks apart into 8 times 2, and then 8 is 2 times 2 times 2, so that's good. And once again, this is an index of 4, which means you got to have 4 friends if you're going to escape. But 3 of them are going to get shot, and still only 1 escapes, okay? And so that's how that works, okay? We're looking for 4, right? And so just so we all understand where those, what happens, it's always the same way. So that index tells us how many of a like thing that we need, okay? Pairs or 3 of a kind, or in this case, 4 of a kind. So I'm glad you all know that, because it gets a little trickier now that we're on free count. So again, here we go. Example 1. Oh, you know what? Let's not do 512 because that was really annoying. Let's do let's just do 64. Okay. Let's pretend it was the square root of 64 because that's easier. All right. So example 1, make sure you put example 1 in your notes and simplify. And this is really key. Use absolute value signs if necessary. This is sort of new. I consider absolute value when we're simplifying radicals. This is real pre-calc material, okay? Maybe your teacher talked about it if you were lucky in Algebra 2, or a lot of you were in college algebra. So this is kind of a new thing, so you might not know about absolute value. So pay close attention today. Okay, so first of all, 64, what's the index here? 2, okay. And so we're going to break down 64 into what times what? 8 times 8. Okay, great. And lo and behold, we've got a match there. So there's 2 8s. If you wanted to, you could write it the square root of 8 squared. That's kind of a more simple way to write that. What is the square root of 8 squared? 8. Yeah, the square root and the squared sort of cancel each other out. It's kind of nice. Okay. Or same idea as before. You've got a pair. 1 gets shot and 1 escapes. All right. So there we go. I'm going to be writing things with exponents in this class, usually. Okay. Negative values. First of all, I want you to notice this is an odd index of 3. And this is a negative 27. There's a couple of ways you could do this, but I'm going to do it a little bit differently. And again, in notes, I'm usually very, very descriptive. I'm going to show all the steps, but maybe you already know the answer, and that's just fine, okay? But I'm going to explain it lots of different ways. I'm going to think about this negative as a negative 1. And in fact, can't I think about it as negative 1 times negative 1 times negative 1? Same thing, right? Still just negative 1. And you can do that all day and night with negative values, right? Okay. And then I'm going to take 27. Now I don't have to worry about the negative. And what is 27? What does that break apart into? 9 times 3. And 9 times 3 is 3 times 3 times 3. So those are really prime factors there, prime numbers. And then I could do the same thing that I have been doing, which is saying I'm looking for a group of 3 of a kind, and here I have 3 negative 1s, or negative 1 quantity cubed. And what is the cube root of negative 1 cubed? Negative 1. And then again, I have all these 3s. I have 3 of a kind there. And what is the cube root of 3 cubed? 3. And so we take those results, and because it's a product inside, it's a product outside, and we just get -3 for our answer. And maybe you already knew that the cubed root of -27 was -3. But I just want to keep that in mind. You can pull off those negatives if it's an odd index. Separate that out, makes it easy. Now, square roots are very different. And I'm taking a very simple example here. And I'm going to use this example to illustrate a new rule. And this is the new rule about absolute values. Okay. So here we have a square root of -5 squared. As I was doing before, we had the cubed root of -1 cubed. The cube root and the cube just kind of cancel out. It doesn't work that way here. Because we actually would have to simplify first. So we would have to simplify under the radical. And what is -5 quantity squared? 25. And then we would say, okay, well, what is the square root of 25? 5, right? And so what I want you to notice is we started with this -5, but because it got squared, and then we take the square root, what happens to that -5? It became positive, okay? That is going to happen anytime you have an even index to an even power, okay? And that's our new rule that we really have to be careful of. So anytime we have an even root with a variable, now this won't happen with numbers, but if it's a variable, like this was a this is me illustrating a point, okay? But you won't see that normally. So if we have the square root of x squared, it's no longer simply x. That would be an incorrect answer. Not wholly incorrect, it's half incorrect, okay? And the reason is because if that x value was -5, what's going to happen to that -5? It's going to turn positive just because of how things simplify, okay? And so anytime you have a variable to an even power under an even root, you have to now remember that I must come out with absolute value because it's always going to turn positive. Okay, does that make sense to you? Okay, super big rule. So let me just illustrate a few more here. So the fourth root of x to the fourth is what? Absolute value of x. Very good. And even the square root, even if it's to the x cubed. I'm going to break that apart a little bit so you can see x cubed I could break apart as x squared times x to the first. Can I do that? Is that allowed?
Yeah.
Yes. Same base, add exponents, that's where we get the 3, right? Now, what is the square root of x squared? Just x? Absolute value of x. And this, x to the first, I can't take a square root of. I don't have 2 of them. And so that stays under that radical. Okay? This is where your book is really not so great. So I had about 6 teachers in here last year discussing this problem. Your book is wrong, which is why you have a worksheet today. The worksheet is correct. And this is how this works. Okay? So watch those even powers, even index, absolute value of a variable, okay? So let's try 2 more, just to make sure we got this. All right, the fourth root of 128, x to the 7th, y to the 5th. Fourth root of 128, x to the 7th, y to the 5th. So that would turn out to be solution. Yeah, good question. That's a very common algebra mistake. Okay, here we go. 128 is divisible by 2. What power? 2 to what power?
6.
2 to the 6th is 64. 2 to the 7th. Very good. Okay. So, x to the 7th, y to the 5th. I'm going to just break this apart a little bit, and I'm looking for 4s here. So, I'm going to rewrite 2 to the 7th as 2 to the 4th times 2 to what power? 2 to the 3rd. Very good. And again, same base, so we would add those exponents, and that's where that 7 comes from. So, I'm going to do a similar thing with this x to the 7th. How could I break that apart in a really nice way?
X to the 4th times x.
Very good. X to the 4th times x to the 3rd. Excellent. And then I'm going to do the same thing with the y. So y to the 5th could be y to the 4th times y to the 1st. Okay. Again, I'm showing all of my steps. You don't necessarily have to do this. If you can get just the answer, fabulous. That's fabulous. Okay. What does Eddie Murphy do? Fabulous, 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 right? Yeah? Okay. All right. So right here, what is the 4th root of 2 to the 4th? 2 comes out. Can I do anything with this 2 cubed? No, he's too small. So 2 cubed stays inside. Then I have the 4th root of x to the 4th. What is the 4th root of x to the 4th? Absolute value of x. Very good. Can I do anything with this x cubed? No, the power is too small. So he's going to stay inside. He doesn't have enough friends. All right. Here we have the 4th root of y to the 4th, which is?
Absolute value of y.
Absolute value of y. Very good. Okay. And then, again, y to the 1st doesn't have enough friends to escape, so he's got to stay inside. This is a lovely answer, but there is one simplification that you might see, and that is that I have an absolute value times an absolute value, which is really the same thing as the absolute value of the product. So I can just move them both together inside one absolute value. So that's a little bit of a simplification. And then, of course, 2 cubed is 8. And if the number isn't super large, then we prefer actual numbers to exponents. Okay? All right, ladies and gentlemen, looking at E, we have the cubed root of negative 16, a cubed b to the 8th. So I'm going to go ahead and think about just this negative as being negative 1 times negative 1 times negative 1. And I can do that all day and night, right? And in fact, could I just write it negative 1 cubed? Quantity cubed? Yeah, okay. I'm going to do that. 16. How can I rewrite 16? 2 to the 4th? It's 2 to the 4th, right? So I'm going to write it as 2 cubed times 2 to the 1st. Is that okay? All right. A cubed is perfect. I like that one just the way it is. And then what should I do with b to the 8th? There's lots of different ways I could do this. I could do 6. Could I do b cubed and b cubed and b squared? If you want to, yeah. My mathematical abilities aren't so hot, so I like small numbers. All right. So the cube root of negative 1 cubed is? Negative 1 gets to come out. So that one's gone. The cubed root, whoops, of 2 cubed. 2 gets to come out. Does that need absolute value? No, it's just a 2. We only have to worry about absolute value if it's a variable. Could be positive or negative, we don't know. But 2 we know. 2 is 2. It's a positive 2. It can't be negative. It is a 2, okay? All right, this other 2 has to stay inside. What is the cube root of a cubed? Absolute value of a. Very good. Oh, no. It's only a. Why don't we need absolute value here? I lied. It's not even. Yeah, this is odd. Oh, yeah, don't have to worry about that. Here you Oh, yeah. Fooled you. Okay. All right. Oh, you're right. It does look like 12. Let me put some multiplication in there. How's that better? Yeah. Okay. Then we have the cubed root of b cubed, which is b. It is, yeah. And then another one, the cubed root of another b cubed is another b. And then last but not least, we have b squared that can't come out. So again, if you clean up that b times b, negative 2ab squared times the cube root of 2b squared. Where did this b squared come from? B times b, yeah. 6b is, yes, the cube root of b to the 6 is b squared. Very good. So again, I'm showing all of my steps, but if you can go from here to here, fabulous. Okay, what you guys need to focus on is how these absolute value things work out, and there's some tricky ones in there. So pay attention when you check your answers. I haven't talked about everything. I want you to question me, okay? All right, ladies and gentlemen, go ahead and, oh, I'm going to pass out a worksheet for you.